Okay, so here we go. All right, so couple of things to keep in mind as I get the notes officially fired up. So
I thought we were doing A-class problems. Just put it back up there.
no.
Dang it.
Wait,
Oh, the notes over there.
yeah. So here we go on this. There are 4 examples, but unless anybody opposes, I plan to do 2 with you, and then I printed out 2. Okay, so that kind of saves you some of that. Then the other thing, just administrative wise, I am not here tomorrow and Friday. So game plan on that is 1, I'm going to tell the sub, finish your homework. Okay. 2, everyone's going to need to take an in-class worksheet, and it's going to be on the stuff that we've talked about the past couple of days. The sub is going to have a key. I'm actually not sure.
It's Cassidy
told me.
Ooh,
so on this, you are going to fill out the worksheet. Again, this stuff is a little bit confusing, so you have a key that you can check with the sub. Don't take it from her, but if you need to check, hey, how to do it, Then the other thing, listen, we don't normally do this, but you will turn that worksheet in. I know that's not a normal practice in this class, but I'm going to tell the sub by the end of the day, which is a half day Friday, you will turn that in to the.
So the worksheet's only on Friday? Or
You'll give it both days,
Okay.
and I'll say work on homework, turn in the worksheet. Everything is due Friday.
Okay.
Yeah. Before you leave, you got to turn that worksheet in. Okay. Questions before we jump into these types of notes here?
just a heads up, it's not Cassidy.
Wait, so
I know.
we can't really talk about it. It'll be done on Friday.
Okay, so everything this week's due on Friday.
All right, so here we go on this. We can balance reactions in a unique way that is focused on oxidation numbers, the stuff that we talked about yesterday, aka transfer of electrons. Most likely, I was talking with Mr. Dorfler, I may put one of these 4 examples on the test. Probably not, though. It's really time consuming. It's hard to put in a multiple choice question, okay? So let's go through that. Number 1, the steps that I'm going to use are from that previous page. Now, what I like to do is this. I like to rewrite this equation exactly how I see it, because I am going to do something with it at the very end. So I'm just going to copy and paste this equation exactly how we see this. And then I'm going to go through this process. Now, on this process, we pick off where we left off the last section of notes, which was determining the oxidation state. So I'm going to do this for this problem here, okay? Copper, it's all by itself. It's in its natural state. So because it's in its natural state, it gets a charge of 0. Now, something some of you were having difficulties, I know Corbin talked to me about it, came in, is where does this thing split? Well, nitric acid, if you looked it up, the plus stuff would be separated from the minus stuff right here.
How do we know that it's in its natural state?
Typically, if it's by itself, or I don't have an example here. Remember that first exception, if it's into O2, H2, those, I think there was 6 or 7. Those are the natural state. All right. A metal by itself, like copper or like magnesium by itself, 0, because it's in its happy spot. It doesn't want to be charged.
Are you going to give us list 7 on the 10?
Yes, you'll get that whole list. Yeah. Now, H splits from NO3. So where you could start with H is this. H on the periodic table is way on the left, group 1. If you went up group 1, what is that positive charge associated with that?
1.
Very good. So we're going to put +1. Then this is a little bit more difficult to think about, but NO3 as a chunk or a block has to cancel out the +1 charge. So in its entirety, NO3 has to be very good. So that's where I start my equation, -1. Now,
Oh,
oxygen almost always has a what charge? -2, -2. On this one here, we have how many nitrogens? 3. So we have 3 times -2, and then we don't know our N for nitrogen. So let's consolidate this. This becomes N -6 equals -1.
But you gotta add the 6.
Add the 6, so what's our,
5, then equals 5.
very good. So I'm gonna write this above this. I'm gonna say N equals that +5. And you guys already told me that O equals our -2, yes. Now, another difficult thing, we have copper and we have NO3, okay? Copper and NO3 is gonna split right down the middle there. And copper, I'm gonna tell this one to you. Copper in a compound is a +2. This is because NO3 is the same ion. NO3 as a chunk has a -1 charge, but we have 2 of them. Now, I'm going to speed things up a little bit because, again, NO3 is written the exact same way. So that means this right here is a +5, which means oxygen, still written the same way, is still a -2. Then, almost, NO2. Start with your oxygen. What's the charge of oxygen?
-2.
Very good. -2, unless it's that special exception. Probably not happening in this class. Now, think about this. We have -2 times total of 2 oxygens. What's our total negative charge? 4. So nitrogen has to counteract that with a +1. Very good. All right. So this right here, I'm going to write it above, is a +4. And then H2O, we split here. What's the charge of oxygen? -2. Hydrogen has to counteract that. There's 2 of them. Any guesses on what its charge is?
0.
Not 0, +1. Because +1 times 2, +2, counteracts that -2. Okay? Now, this takes a little bit of time. So we only are really interested in 2 elements, and those are the 2 that change their numbers. Copper goes from 0 to a +2. Yes?
Why is the O2 -2? It's not.
Good, sure. Okay. Copper goes from 0 to +2. So what's its increase in charge?
Going positive, so it's a
+2.
but it's
Wait, what?
something in there. It's oxidizing, but it's the opposite.
It's a +2. So what we're going to look at is this. All right, I'm going to go copper to the copper compound. This right here was a +2. Now, the only other thing that changes its charge, nitrogen and HNO3 is +5, in NO2 +4. So if we went from +5 to +4, what's its overall change?
-1.
Very good. -1.
Is that?
That's good. It technically is reduced, so it is the oxidizing agent, yes. Now, what we have to think about is this, all right? We got to even out these charges, all right? We have a +2. We have to cancel it with a -2, but we only have -1. So we got to multiply this by what to get to that? We got to multiply it by 2. What happens in this scenario is this. That means this compound, HNO3, has to get multiplied by 2. This compound, NO2, has to get multiplied by 2. So I'm going to rewrite this as such. Cu plus 2HNO3
Can you turn on projector maybe?
Yes, I can. Give me a second though. Gives us CuNO3 2 plus R2NO2 plus H2O. Now, here is our double check here. Here's our double check. We get to this and we say, all right, we worried about our N's for nitrogen, so we go back and double check. On the left, we have 2 times 1, that's only 2. But on the right, we have 2 from NO3 plus another 2. So what's our total NO or our nitrogens, N's? 4. So this is our double check, and it's kind of a weird step. We got to come back and say, well, by doing that, we need to have a 4 to make sure everything's balanced, okay? I don't necessarily like balancing this way. It is a method to the madness. Any questions on this? All right, let me take a moment to get the
Attendance.
let me take a second to get the actual thing fired up on the projector here.
Stop fighting.
Hang on.
Is she in like
Yeah.
double?
Somebody go back.
Hang on, I'm not-
Podcast online.
Yes, Kaylee.
Why did it change to a 4 if 2 times 2 is already 4?
That's why.
So we're balancing, it was up on the right-hand side, so we had to counter it on the left-hand side.
Okay.
It's a very odd way to balance an equation. Yeah, sure.
Will said stuff.
Good. Okay, so like I said, this is a very odd way to balance an equation. All right, I don't necessarily like this way. There's one more example, but I printed out the example. So first question, does anybody need this? Okay, the next way, there's just a little bit of an added step, and it's because it's in an acidic solution, which I think is much better explained in this alternate method that I show you how to do this. So we do essentially the same steps. We go through it, we find the oxidation numbers, yada, 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 and we end up with this. Now, again, I necessarily don't really like how it's done, but what I've done is I have a written out set. Take one of these. This is this problem here.
Is it on that paper?
It's on that paper. Yes. Yep.
Which other one are we doing?
So we're going to do one more, and that is half reactions. Now, this is the method I prefer. It's probably a little bit longer, but it's easier to follow these steps. So we're going to follow these steps, and it starts out and it says, hey, put them into oxidation and reduction half reactions. We don't even have to do that, but we do need to follow the portion of step B, okay? So here we go on this problem here. One important thing, if we balance via half reactions, it has to tell you, hey, this is in an acidic or a basic solution. So we're going to start with this. And it says divide into oxidations or reduction half reactions. All you have to do is pick one of these things. So I'm going to start with the first reactant, and it's going to be MnO4 minus. And now technically it should have that AQ for aqueous, but for space, I'm going to eliminate. Now, I'm going to block out the remaining reactants, which there's only one remaining reactant. I'm going to draw my arrow. I'm going to ask you this. Of these two products, Mn2 plus or CO2, which more closely matches MnO4? Okay, very good. So this right here is 1/2 reaction. So we don't even need to know if it's oxidation or reduction. Now technically, because I've done this problem, it is reduction, but it doesn't matter. Yeah,
So if we were to choose the C2O4, we'd go for the CO.
exactly. And that's going to be our next step.
Okay.
Yeah, so you could start there, yes. Now, what we're going to do is this. We're going to go through the steps here, and we are going to do this first. It says balance every element except H and O. So if we look here, we have one Mn and one Mn on the right. So there's nothing else besides H and O we have to worry about. And so here we go with our steps. Over here we have 4 O's. The steps say to balance out your oxygens on the opposite side, you add that many H2Os. So now we have 4 O's. 4 O's. Here's the problem that it's created. We now have 4 times 2, which is how many? 8. We have 8 H's. So to counteract your H's, what they say to do is add our 8 H's as H pluses. Okay? Then our final step that we need to worry about for this half reaction is this. Our total overall charge on the left and right needs to be the same. So over here we have 8 times a positive 1, so positive 8, plus a negative 1. So what's positive 1 plus a negative 1?
0. Wait.
Positive 8
Oh,
minus 1, essentially.
Oh, 7.
7, right? So over here, I'm going to write this above. This side of the reaction is a plus 7. On this side of the reaction, we have a positive 2 plus 0. So what's its overall charge? Positive 2 plus 0? Positive 2. Now, we have to equal the charges out, and the only way that we can do this is by adding electrons. Electrons, are they positive or negative?
Negative.
They are negative. So we're going to have to add it to this side that's a higher weight or a higher number. So ask yourself, 7 plus some negative number needs to equal 2.
-5.
Okay, so we do this. We need 5
H minus.
electrons. Okay, our charges at this point are even, and at this point we've done all that we can for this reaction. So now we turn to our other reaction here, and we're going to start with C2O4. Now, C2O4 has a 2 minus charge. Again, you can ask yourself, we've already used Mn, but only other remaining product is CO2. Now we first balance every element besides O and H. So carbon, there's 2 of them on the left, but only 1 on the right. So what coefficient needs to go in front? 2. Now on the left, we go to our oxygens and we say we have 4 oxygens. Over here we have 2 times 2, which is 4. Because our oxygens are even, we don't need to add H2O. Because we don't add H2O, we don't have to worry about our H+, but we do need to worry about charges. On the left, there's a 2 minus charge. On the right, there is a charge of 0. So first off, the right-hand side needs electrons. And if this is at 0, how do we get that right-hand side down to a -2? We need
2E.
There you go.
Negative.
All right, so that's our general setup. Now, we've done a very similar step. We called it Hess's law earlier, but we need to cancel out our electrons by multiplying our reactions. So our electrons need to cancel. So ask yourself, where do 5 and 2 meet if we have to multiply these things? Yeah, 10 electrons. So we have to do this with our top equations. We have to get to 10 electrons, so we say 5 times 2 for only the top reaction. And so we end up with this. 5 times 2 is 10 electrons plus 2 times 8 is 16 H pluses plus our MnO4 becomes 2 MnO4 minus. That leads us to 2 Mn2 plus 8 H2O. Okay, cool. Now, just like we've done before, I would highly suggest putting a line through this so we don't confuse it. And then we move to this bottom equation. We're going to have to
multiply by 5.
Very good. We got to cancel out our electrons there, so we got to multiply by 5. And so we're left with this. We have 5 C2O4 2 minus. That gives us 2 times 5 is 10 CO2. Yep. Now, we add these equations together to get to our final answer. But remember, when we add equations together, items that are the exact same on opposite sides of different equations can cancel. And I will be honest, only our electrons can cancel. Now, your check on this method, if your electrons don't cancel out exactly, you've done something wrong in previous steps. So all we have to do is add these things together, and our final answer would be this. We would get 16 H pluses plus 2 MnO4 with a minus plus 5 C2O4 with a 2 minus gives us, up top again, 2 Mn2 plus 8 H2O plus 10 CO2. Now, if you're really wanting to double check this, you can. There's 2 checks that you can do. Check one is that you can make sure you have the same number of atoms on the left and right hand side, which we do because I've done this problem before and this is what I've got. Number 2 is the charges in your overall balanced equation have to be the same. So you can add up the charges, and those charges that actually end up being a positive 4 on each side there, they do cancel out, okay? Questions? Again, yeah, this is a very tedious method. I really just wanted to introduce this to you, but does anybody need this example? Okay, I just want to show you one more thing, and that is this. We can do the same thing if we're in a basic solution. Remember from last chapter, OH minus, that has to get factored in. I have already done that problem on that sheet that I handed out, and it turns out to be like this. Again, the only thing different in our balancing is we added those extra OH minuses. Okay? Questions?
I have no questions.
Okay, so let me stop the recording.
Not post the homework.
The homework